Hey everyone, welcome back. Today we're going to talk about quadratic equations and really how to solve a quadratic equation. A quadratic equation, ax squared plus bx plus c, is in standard form when you set it equal to 0. And remember with our quadratics, a, b, and c are constants, and a can never be 0. We need that x squared term in order for it to be a quadratic. Now, what is a solution? A solution is whenever you have an x-intercept. So here we have three possibilities for solutions. In the first graph, here we have a quadratic that opens downward. And remember, they can open upward or downward. It doesn't matter. I just wanted to give you a few different examples. This quadratic opens downward, and it never crosses the x-axis. So there's no intercept and therefore no solution. In the second example, where this quadratic is opening upward, it crosses the x-axis here. Actually, the vertex is touching the x-axis. Since there is one x-intercept, there's exactly one solution for this quadratic. And then the third possibility on this third graph, we have two intercepts. These two places where our graph is crossing the x-axis. Those two intercepts would be the two solutions for this quadratic equation. Now, the book talks about three different techniques that you can use to solve quadratic equations. You can solve symbolically. This is my preferred method. Symbolically means just using math and your mathematical operations. Now, I prefer to solve symbolically because you could have x-intercepts that do not intercept on a whole number. So what if you have an intercept of 1/2? If your graph is slightly off, it's going to be hard to see. But as long as you're doing good math, you're going to get the correct answer. Now, the next option is numerically. This is making a table of values. So picking x values and y values and solving. And then you're looking for those x-intercepts. Or graphically. Graphically is great, but again, if those intercepts aren't whole numbers, you could have some issues. So let's look at this first example, and we're going to solve symbolically. And we need to solve this with factoring. So we have 4x squared plus 13x plus 9 equals x. The first step to solve this symbolically is to have it in standard form, or equal to 0. So we need to move this x that's on the right-hand side over to the left-hand side with all the other x's. We're going to subtract x from both sides, and we get the standard form, 4x squared plus 12x plus 9 equals 0. Now, because our leading coefficient isn't 1, it's 4, we're probably going to want to rewrite this so that we can factor with grouping. So we need to find that key number, a times c, 4 times 9, which is 36, and b, which is 12. So we need two numbers that multiply to 36 but add to 12. That would be 6 and 6. So we rewrite our middle term. We have 4x squared plus 6x plus 6x plus 9 equals 0. Now we group the first two terms, pull out their GCF of 2x. We're left with 2x plus 3. We group those last two terms. They have a GCF of 3. And we're left with a 2x plus 3. And now the two terms that we have a GCF of 2x plus 3. And it leaves behind the binomial of 2x plus 3 equals 0. Now, both of these binomials that we factored down to are identical. So we really only have one solution. 2x plus 3 equals 0. And now we just solve for x. Subtract 3 from both sides, and we have 2x equals negative 3. And divide by 2. So x equals negative 3/2 is our solution. And remember, a solution is an x-intercept. So it's really the point negative 3/2, 0. Now let's look at another way that you can solve quadratic equations. That's called the square root property. The square root property is used when you have a constant k that is greater than or equal to 0. Then the solutions to the equation x squared equals k are found by taking the square root of both sides, and you get a plus or minus the square root of that constant k. So example 1 and 2, we're going to use the square root property to solve. And to do that, we need to rewrite it so that we have our x squared all by itself on the left-hand side. So here we need to add 64 to both sides. And that brings us to 5x squared equals 64. And we need to divide by 5 because we need to isolate that x squared. So x squared equals 64/5. And now we take the square root of both sides. Because when we take the square root of x squared, we get x. And when we take the square root of the right side, we get plus or minus the square root of 64/5. And we can take the square root of that numerator, 64, so this will simplify to plus or minus 8 over the square root of 5. Or you can rationalize that denominator and get plus or minus 8 square root of 5 over 5. If you forgot how to rationalize denominators, I would go back to that video and rewatch it. But you're just multiplying the denominator and the numerator by the square root of 5 and then simplifying. Let's look at example 2. Here we need to subtract 16 from both sides in order to isolate that x squared. So we have x squared equals negative 16. And then we need to take the square root of both sides so that we get x equals plus or minus the square root of negative 16. Now, remember we just learned that we can take square roots of negative numbers. It just gives us an imaginary answer. So the square root of 16 is 4, and the square root of the negative 1 multiplied by the 16 is I. So x equals plus or minus 4i. Let's look at another way you can solve a quadratic equation. This process is called completing the square. And there's 4 steps you need to follow to complete the square. First, you need to write your equation in this format, x squared plus bx equals d, where x squared has a leading coefficient of 1, and d is your constant term. So we're not putting it in standard form where it's equal to 0 anymore. We need to move the constant to the right-hand side. Then we're going to add b over 2 squared to both sides of the equation. And in step 3, we're going to factor the perfect square trinomial on the left-hand side. Because when we complete the square, adding this b over 2 squared to the left-hand side, it creates a perfect square trinomial. Then in step 4, we use the square root property to solve for x. Yep, sounds a little chaotic, but let's walk through it and you'll see it's not that hard. So step 1, we have to write our given equation in the form x squared plus bx equals d. So we need a leading coefficient of 1, we have that here, and we need our constant on the right-hand side. We also have that. Now we need to determine what b over 2 squared is. Well, our b is negative 2. So we have negative 2 over 2, and then we have to square it. Or it's negative 1 squared, which is just 1. That was step 2. Now we add this to both sides. That would give us x squared minus 2x plus 1 on the left, which is a perfect square trinomial, equals 24 plus 1 on the right. Now we can factor the perfect square trinomial on the left, and we get x minus 1 squared equals 25. Now you apply the square root property, right? The left-hand side is something squared. So if we take the square root of it, and we take the square root of the right-hand side, we would get x minus 1 equals plus or minus the square root of 25. Well, we can simplify the square root of 25. So we have x minus 1 equals plus or minus 5. Now we need to solve for x. We need to continue to isolate x. So we'll add 1 to both sides. That gives us x equals 1 plus or minus 5. Now this plus or minus is telling us there's two possibilities. What it says is that x equals 1 plus 5 and x equals 1 minus 5. So on the left, x equals 1 plus 5, or x equals 6. And on the right, x equals 1 minus 5, or minus 4. So here we have two answers. X equals 6 and x equals negative 4. Let's complete the square again, but here with example 2. First, we need to move this constant term to the right-hand side. So let's add 7 to both sides. That gives us 4x squared minus 8x equals 7. Now notice that our leading coefficient isn't 1, it's a 4. So we need to divide all of our terms by 4. And by dividing by 4, now that first term is just x squared. And our second term becomes minus 2x. And the right-hand side is 7/4. Now we can move on to completing the square. We need to find b over 2 squared. Again, b is negative 2 over 2 squared, or negative 1 squared, which is 1. Then we add that to both sides. X squared minus 2x plus 1 equals 7/4 plus 1. We can factor the left-hand side because it's a perfect square trinomial. It's x minus 1 squared, and that equals 7/4 plus 1. Well, let's rewrite that 1 with a common denominator to the 7/4 so we can combine it. So that 1 would be the same as 4 over 4, or this is x minus 1 squared equals 11/4. Now we can apply the square root property. Take the square root of both sides. So the left, we get x minus 1. And on the right, we have plus or minus the square root of 11/4. And we can simplify that right-hand side. We have x minus 1 equals plus or minus the square root of 11 over 2, because we took the square root of 4. Now we need to add 1 to both sides, and that brings us to x equals 1 plus or minus the square root of 11 over 2. You can leave it like this, or you can get a common denominator for that 1, which would be 2 over 2, and then you can simplify this further. Since we have a common denominator, we can combine this into one fraction. 2 plus or minus the square root of 11 over 2. Now, occasionally you might be asked to rewrite an equation or solve an equation for a specified variable. Here we're asked to solve x equals y squared minus 1 for the letter y. So let's see what we have to do to isolate that y. Well, right now it's y squared minus 1 on the right. So if we add 1 to both sides, we're left with just the y squared on the right. And the left is x plus 1. Now I'm going to rewrite that. That's the same as y squared equals x plus 1. And because it's y squared equals something, we can apply that square root property in order to solve for y. So we take the square root of both sides. And taking the square root of both sides gives us y equals plus or minus the square root of x plus 1. So remember, you can use that square root property whenever you have something squared equals something else. You take the square root of both sides. Don't forget that plus or minus in front of the square root on the right-hand side. And then simplify. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.